Let's go ahead and consider question number 6. This is DSC 2021 question. Let's see what the question is saying. A right angled triangle. So we have a right angled triangle. Has two equal sides. So it tells us that these two sides are equal. It's an isosceles triangle also. Of 1 inch each. This is 1 inch. And this is also 1 inch. One of these sides drawn horizontally is divided into n plus 1 equal proportions. So, just see here. I'm dividing this equally. So, this one is divided into n plus 1 equal proportions. Which means this is 1 upon n plus 1. This is again the next 1 upon n plus 1 is like this. This divided into 1 upon n plus 1 equal proportions. So you can consider it like this. So supposedly it is of 1 inch. And I say n is 4. So I divide it into 5 pieces. So each piece is what has this height, length of 1 by 5. This width, sorry, of 1 by 5. This is 1 by 5, 1 by 5, 1 by 5, 1 by 5, like that. Okay, so this is what the question is saying. On each proportion after the first, a rectangle is formed with the height equal to vertical distance from left hand end portion of the hypotenuse of the triangle. So what are we doing? We're going ahead and we are formulating a rectangle over and above it. Something like this. This is the first rectangle. This is the second rectangle, third rectangle, fourth rectangle, fifth rectangle, sixth rectangle, like that. I have formulated various rectangles. Now it says find the sum of the rectangle areas. Now please see this. This rectangle that I have formulated, I have tried to cut it here, and then this is what is the length of the rectangle. So what is this length is what I want to understand. To understand that, just see that this is an isosceles triangle. So whatever is left here is exactly what will be left here. And what is left here? I know that this width was 1 upon n plus 1. So this will also be 1 upon n plus 1. Which means that this length will be 1 minus 1 upon n plus 1. Which will be n plus 1 minus 1 upon n plus 1. Which will be n upon n plus 1. So for the triangle 1, I have the length as n upon n plus 1. And the width as 1 upon n plus 1. This is the first rectangle, sorry. Now look at the second rectangle. For the second rectangle, how much am I leaving out? Do you see that if I take this here, I'm leaving out 2 proportions. And the remaining is its length. So for the second, if I just zoom this a bit, for the second rectangle, I am leaving 2 1 upon n plus 1 portions and leaving that. The remaining is my length. So this will be 2n, this will be 2, sorry, this will be n plus 1 minus 2 upon n plus 1. This will be n minus 1 upon n plus 1. This will be its length. And width is the same, 1 upon n plus 1. Then I will go to the third rectangle. For the third rectangle, if I have to find out what its length would be, if I take it here, I'm leaving 3 n plus 1 proportions. So for the third rectangle, its length will be 1 minus, I'm leaving 3 n plus 1 proportions. So it will be n plus 1 minus 3 upon n plus 1. This will be n minus 2 upon n plus 1. This will be its length. And what will be its breadth? Same, 1 upon n plus 1, and so on. So basically what will happen is that these rectangles that you would be formulating, the length of the width of the rectangles would be the same. The width would, all of them will have a width of 1 upon 1 plus n. But the breadth, or the length would keep changing. For the first one, the length would be n upon n plus 1. The second would be n minus 1 upon n plus 1. The third would be n minus 2 upon n plus 1. Next would be n minus 3 upon n plus 1, and so on. Now it says, find the sum of rectangle areas and its limiting value. So first of all, let me find the sum of the area. What is the area? Area is length into breadth. So it will be n upon n plus 1 whole square, n minus 1 upon n plus 1 whole square, n minus 2 upon n plus 1 whole square, n minus 3 upon n plus 1 whole square, and so on. So if I have to add it, it would be a series. So let's find the sum of all the areas. N upon n plus 1 whole square plus n minus 1 upon n plus 1 whole square, and so on. So, n minus 2 upon n plus 1 whole square. I can take n upon 1 plus n, 1 upon 1 plus n whole square common, and what will I get? I will get n plus n minus 1 plus n minus 2, and so on. But isn't this the sum of first n natural numbers? And we know that the sum of first n natural numbers is n plus 1 by 2 into 1 upon n plus 1 whole square. So this will get cancelled, and I will get n upon 2 n plus 1. So this would be the sum of my series, n upon 2 n plus 1. So if I have to check this, the answer would be this, n upon 2 n plus 1. It's not coming anywhere, first of all. So B is the correct answer. But let's find its limiting value also. So to find the limiting value, it's very simple. I will say let limit n tends to infinity, n upon 2 n plus 1, and I will divide numerator and denominator by n. So I will get 1 upon 2, 1 plus 1 by n. And now I will just approach this to n tends to infinity. So it will be 1 upon 2, 1 plus 1 by infinity. Anything by infinity is 0. It will be 1 by 2. So its limiting value will be 1 by 2. So the answer to this question is B. 1, you have to understand that this was an isosceles triangle. Within the isosceles triangle, I was formulating these various rectangles. The first important technique was to find out the length of the triangle. That was the most important, length of the rectangle, sorry. So I was forming these various rectangles. You have to form the length of the rectangle. And after formulating the length of the rectangle, then it was easy. You just do length into breadth, you get the area, you sum up the area, you get the answer, and then you find the limit. Right? Okay. So the answer is B. This question actually uses the properties of vector. So it says x square plus y square plus z square is 1. Just tell me if you could think of any other way of solving it. We can discuss that also on the group. So find the maximum value of minus x plus z. So what I have done is I have formulated this into two vectors. एक property vector की लिख लेते हैं. देखो, if I have two similar vectors,
then their dot product will be 1. But if I have two different vectors, just say I into j, its dot product will be 0. I into k, its dot product will be 0. So I have just tried to go ahead and divide this part, x square plus y square plus z square. Achha, this is given to me. First, let's just think about this. So I have gone ahead and written x iota plus yj plus zk, and I have multiplied this with minus I plus k. Just think why I have done this. This is asking me to find minus x plus z. Okay. Which means that if I go ahead and I write this as xi plus yj plus zk, and I do a dot product with minus I plus k, देखो I का I के साथ will become 1. And then I have this minus x, so this will become minus x. I का k के साथ will become 0. J का I के साथ will become 0. J का k के साथ will become 0. K and I will become 0. And the last thing I will be left up with plus z, and k dot k will become 1. So I will get minus x plus z. So when I do the dot product of this vector with this, I will get this vector. But we have this rule that the dot product of two things, two vectors, is magnitude of the first vector into magnitude of the second vector into cos theta. So the magnitude of the first vector, right, will be what is coming with this, that is x square, what is coming with this plus y square, what is coming with this plus z square. Magnitude of this vector is its coefficient minus 1 square plus its coefficient 1 square. That is its magnitude. ये इनके magnitude हुए, right? So when I find the magnitude of this vector, I will get x square plus y square plus z square under root. And when I find the magnitude of this vector, I will get minus 1 square plus 1 square under root into cos theta. But this is given to me in the question that this is 1. So I will replace this with root 1. And this is given to me as, this I will find as root 2. So this is root 2. So I have got that u dot v, this is root 2 cos theta. And यही dot product ही तो minus x plus y निकला था. So I have got that minus x plus z is root 2 cos theta. Now just think about this. It is asking the maximum value. I know that cos theta, this is a cyclic function, right? Cos theta goes from 1 to minus 1. So the maximum value cos theta can take is 1. That's the maximum value of cos theta. So if I put the value, maximum value of cos theta, I will get its maximum value as root 2. Agar suppose they would have asked the minimum value of this function, minimum value of minus x plus z. So what's the minimum value cos theta takes? Minus 1. So I would have said root 2 into minus 1, minus root 2. Simple. So this is an excellent question because it is, there you think if you can think of doing it another way, but because this is a 3-parameter value given, and I have to maximize a 2-parameter value, using vectors makes it very simple. So the answer to this question will be root 2. Let's come to the next question. Consider, this type of question I have just done today for your problem, for your question bank also. What do I want to talk about in this question? See, a lot of times when they give you a particular kind of case, just for example, here they are saying, consider any real valued function f defined on the set of all real numbers, f of x is x. If f is not identity function, which of the following is true? Now in these cases, you have to go ahead and assume some value of the function. If you don't assume some function, it will become very difficult for you to solve. Just say, for example, let's say there is a question. And this question says that, you know what, your function f of x, this is greater than 0, f dash x is greater than 0, f double dash x is greater than 0, then find something they have given. Or is this function following the properties? They have given you some explicit properties of the function. They haven't given you any function. You cannot do these questions unless you assume some function which follows all these three properties. And one classic example, this will only come with practice. One classic example of this is when your function is e to the power x. Exponent function is greater than 0. You find f dash x, that's also greater than 0. You find f double dash x, that's e to the power x, that's also greater than 0. So sometimes they will give you some properties of the function, but you can only solve that question by assuming some function and not directly. Very similar thing is happening here. Let's have a look here. So I have gone ahead and I have taken my function to be a minus x. You can take any function as long as it follows this property. I will show you multiple other functions. So for example, if I go ahead and I take my function, see if this follows. Suppose my function is 1 by x. So what will be f of x? It will be 1 upon, instead of x, I will replace it with the function 1 by x and I will get back x. That means this is also following this property. If I take my function to be a minus x, then I will take f of x. So instead of x, I will replace it with the function once. I will replace it with the function. So instead of x, I will write a minus x and I will get back x, right? So you have to go ahead and you have to assume a function such that it follows whatever property is given to you. Now in this case, it is asking whether it will be decreasing or increasing. Take lo nikal ke. When function is this, what is f dash x? Minus 1 by x square. This is less than 0. Because of this negative sign, that means it is decreasing. Let's say your function I have taken is a minus x. Then what will be f dash x? It will be minus 1, which is less than 0, which means the function is decreasing. Let's say I take the function as minus x. Then f of x will be, instead of x, put the function. Function was minus x, it will be x. It is also following the property given to you. What will be f dash x? Minus 1, less than 0, decreasing. So we see that when we take a function such that f of x is equal to x, we see that it is a strictly decreasing function, that the derivative of it is negative. But to make these functions, you need practice. You have to do these questions again.
This is DSC 2021, question number 1. Let's see what the question is saying. Consider the problem of maximizing the function with respect to x, y, and it is subject to a constraint. Now please see this. You're given a function. You want to, this function no doubt is a function of b. It has this constant b also in it. But you want to maximize this subject to a constraint. And the two variables given to you are x and y. B is a parameter, it takes some value fixed greater than 1. So b is greater than 1. Now it says let v be with a minimum value attained, that is a function of b. So now it just switches this question. And it says consider another function VB. This is a new function. This VB is only a function of B. This is what it is saying. Then it says consider V dash B be the derivative of VB. Okay. So V dash B is the derivative of VB. Whenever you have to minimize, because VB is the minima, whenever you have to minimize any function, what do? You find its derivative and you equate it to 0. Only that gives you the answer of the minima. Isn't it? So if you have a function for which you want to find the minimum value, what will you do? You will find the derivative of the function and equate it to 0. And that derivative that you will find, that will also be a function of B. Only that will give you B star. Isn't it? So this is nothing, but we just have to say that the answer is V dash B equal to 0.
DSC 2021 paper. So the first question says, consider the problem of maximizing a function, and this function has to be maximized with respect to x and y, and you're given a constraint. The constraint is x plus y, and it says b is some parameter in this that takes a value greater than 1. VB is the maximum value attained. मतलब जब ये function maximize हो गया, when you maximized this function, the maximum value that you get out of this function, that is represented by VB. So the maximum value of this function will be called VB. Now, after you find that maximum value, it says let V dash B be the derivative of VB. Which of the following is correct? So you're supposed to go ahead, differentiate that maximum value that you have attained with respect to B, and then give the answer to the question. Okay. So let's see what I can do. See, there are 2 ways to solve this question. Actually, 3 ways. Let me take you through all 3. The first one can be that you form a Lagrange, right? And when you go ahead and you form a Lagrange, you go ahead and say that this is my function. Yeah, VB will be the minimum value attained as a function of, this is what it says, correct. So you go ahead and you form a Lagrange. So after you form a Lagrange, subject to a constraint is x plus y equal to 100, you try to minimize it because it is saying the minimum value attained. That's the first way possible. The second thing that you could have done is that you use the method of substitution. Both these methods are correct. You use the method of substitution and you go ahead and say, okay, if x plus y is 100, y will be 100 minus x. You put it in your subjective function and get this objective function and get this as a function of x only. And then you minimize it because you want to find the minimum value attained. That's also correct. Now, one other thing which many students did last time, which I don't find it correct, but I'll say this is a tukka that the answer came correct. They simply said, ki ma'am, if VB is the minimum value, then V dash B should have been equal to 0. I don't agree to that. V dash B is the derivative of the minimum value. The derivative of the minimum value may or may not be 0. I'm finding the different derivative of something, right? So VB is the minimum value of the function, right? And V dash B is the derivative of that minimum value. So it may or may not be 0. So I think that although in this case, people got this correct, people got V dash B equal to 0 as correct using the third method also. it's not a good idea to go ahead and use that one. Now let's see how to solve this question. So I am using the method of substitution, but it is up to you. If you want, you can do through Lagrange also. Let's take this function x square plus 2x plus by square. And let us go ahead and subject this to constraint x plus y equal to 100. So from this y, what will I get? I will get that my y is 100 minus x. I will go ahead and put this y in this function. So instead of y, I have 100 minus x here. And here also when I will put it, instead of y, I will get 100 minus x. Now, because they're telling me that this VB is the minimum value attained, we will go ahead and find the minimum value of the function. And how do you minimize the function? You differentiate the function and you equate it to 0. Now, the only variable I can differentiate it with is x. So differentiation of x square will give you 2x. Then here, this is 100 into x. So differentiation of 100x will be 100. This is minus x square. So differentiation of minus x square will be minus 2x. This 2 will remain as it is. Plus, I will use chain rule here. So 2 will come down. So 200 minus x. And differentiation of minus x will be minus 1. And you will get it equal to 0. So when you differentiate this with respect to x, this is what you will get. You can just go ahead and open this up. You will get 2x plus 200 minus 4x minus 2b100 plus 2bx equal to 0. Now just see what I have done. I have just tried to simplify this. So, between 2x minus 4x, I will get minus 2x. And then I will get this 200 as it is. And here, if you take this, you will get minus 200b plus 2bx. Now, you can go ahead and between this and this, take 2x common, you will get b minus 1. Then between this and this, take 200 common, you will get 1 minus b, right? So if I just revert this, I can just write it as minus b minus 1. Now you can just take b minus 1 and you will get this answer. So kuch nahi kiya hai, abhi tak I have just differentiated the function and equated it to 0 because I want to minimize the function. Now think about this. The question tells me that b is a parameter taking some value greater than 1. Now here I have got that this is equal to 0. When will this be equal to 0? This will be equal to 0 if either x is 100 or b is 1. But b is greater than 1. This is what the question says. So I cannot have b equal to 1. This is not possible. That means the only value of x that I will have will be x is equal to 100. So now I have to check whether the function is actually minimized or not. So what can I do? I can just go ahead and differentiate the function again with respect to x. When I will differentiate this function again with respect to x, I am getting 2b minus 1. Yahan se dekh lo, differentiate karke. This is your first order differentiation, del f by del x. If you differentiate this with respect to x, 2x ka differentiation will be 2 and b minus 1 is a constant. So you will get 2b minus 1. The question tells you that b is greater than 1. So which means this will be positive. That means this entire thing will be positive. So when your second order derivative that is positive, what have you done? You have minimized your function. So what do we see? We see that the function has been minimized. Now let's go back. Question is very easy. It's just that they will change the language. They said minimize the function. We have minimized the function. Then they're saying VB is the minimum value attained. So value nikal lo, minimum value. When is the minimum value? Minimum value is when x is 100. What was y? Y was 100 minus x. So it will be 100 minus 100 which will be 0. So what will be the minimum value that you will get? The minimum value will be just put in this function x equal to 100 and y equal to 0. So you will get 100 square plus 200 into 0 plus b into 0 square. So you will get the answer as 100 square. So the minimum value of the function is 100 square. ध्यान से देखो. They said that the minimum value of the function उसको VB बोलना है. तो हमने इसको VB बोल दिया. But is this a function of B? No. Which means this is a constant function. You take any value of B. B की कोई भी value हो. VB will be 100 square. This is what my VB is. It's not a function of B. It is not getting affected by B. This is what my minimized value is coming. We have got this minimized value. Now finally what it is saying? It is saying once you find this minimized value, find the derivative of that minimized value. Okay, iska differentiation nikal lo with respect to B. So if you will differentiate V with respect to B, you will get 0 because this is the constant. So the answer is V dash B is 0. That's the answer to your question. So third one is the correct option. Very easy question. Just follow the steps. They said minimize the function. We minimized it. They said VB is the minimum value. We found the minimum value. They said differentiate the minimum value. We differentiated that and we got the answer.
Okay, now we will take question number 4. This is DSC 2021 paper. Let's see what the question is saying. Find the value of submission of the series. So I have to sum the series R from 0 to 100. And this is 100 to R. Let me put R equal to 0. So I will get 100. 2 into 0 is 0. Let me put R equal to 1. So I'll get 102. Let me put R equal to 2. So I will get 100. 2 into 2. And I will put 1. When I will put 2, it will be 100. 2 into 2, which will be 4. And so on. If I keep doing that, and I put, finally, I will go ahead. This will be 50. I will put 50. So I will get 100. 2 into 50, which will be 100. So this is nothing but 100C0 plus 100C2 plus 100C4 and so on till 100C100. Now there are 3 properties of combination, permutation and combination that you have to remember. And those 3 properties are very, very important. So let's just do those 3 properties once. Property number 1, NC0 plus NC1 and so on till NCN. This is 2 raised to the power n. Okay. Second property, NC0 plus NC2, just taking the even ones, plus NCN. This is 2 raised to the power n minus 1. And property number 3, if I just take odd ones, NC1 plus NC3 plus NC, I'm just taking odd ones. This is also 2 raised to the power n. So if I sum all NC0 to NCN, I get 2 raised to the power n. If I take only the even ones, do you see that I'm just taking the even ones, NC0, NC2 till NCN. This is 2 raised to the power n minus 1. And if I take only the odd ones, then also it will be 2 raised to the power n minus 1. Now let's go here and check. Here I'm just taking the even ones. So the sum is going to be 2 raised to the power n minus 1. And what is n here? N is 100. So this is going to be 2 raised to the power 100 minus 1. 2 to the power 99. So the answer is A. You just have to remember these three formulas, these three identities of combination to solve this question. For us, only this one was relevant. So, you know, if you ask me what will be 4C0 plus 4C2 plus 4C4, I will not go ahead and start finding this out, that this is 4 factorial, 0 factorial, 4 factorial, plus 4 factorial, 2 factorial, 2 factorial, plus 4 factorial, 4 factorial, 0 factorial. I won't do that. I will simply say that I am taking the sum of all the even and I'm adding them together. It formulates a series, and this, you know, the sum of such a series is 2 to the power n minus 1, because I'm only taking odd even numbers. Had I taken 4C0 plus 4C1 plus 4C2 plus 4C3 plus 4C4, then it would have been 2 to the power n. So I would have simply got 2 to the power 4 as the answer. Here I will get 2 to the power 3 as the answer. So I just have to remember this series, how to find the sum of the combinations, and that will solve the answer for this one. Consider question number 2 of DSC 2021 paper. What is this question saying? Consider any real valued continued function defined on the set of all real numbers defined such that f of x is equal to x. This is given. For all x belonging to the real number. Then it says if f is not identity function. So what is an identity function? An identity function has a property that f of x is equal to x. So if y is equal to x, then it is an identity function. F of x has to be equal to x, then it is an identity function. So it says f of x is not equal to x, because it says it is not an identity function. Not identity function. This is given to us. Then it says which of the following is true. So please say, see, two things are given to us. One, f of x is equal to x. Second, f of x is not equal to x. These are given to us. And based on this, it is asking which of the following property is true. Now, to go ahead and do this, you will always try to formulate any function which will satisfy both of these properties. So let's say that I take this function where f of x is equal to 1 by x. It is not equal to x, so it is not an identity function. Now what I do is I find f of x, which means wherever my x is there, instead of x, I will put fx. So let's go ahead and do that. I want to find f of fx. Instead of x, I will put fx. So I will get 1 upon fx. Fx in itself was 1 by x. So this will be what? This will be 1 by 1 by x, which will be x. So I have got two things now, and I have been able to satisfy both the properties. F of x is x. I have satisfied this thing. F of x is not equal to x. I have satisfied this also. Now, based on these two, what I can go ahead and I can do is I can find whether this function fx is increasing or decreasing. So if my fx is 1 by x, I clearly know f dash x will be minus 1 by x square, which is less than 0 for all x. Whether x is negative or positive, it is always less than 0, which means it is a strictly decreasing function. And if you notice, you will see that this is actually 1 by x is actually a rectangular hyperbola. Fx is equal to 1 by x. So it is a strictly decreasing function for all values of x. Therefore, I can say that the answer is B. F is a strictly decreasing function. This is DSC question number 15, paper 2020. Let's see what the question is saying. So it says x and y be jointly normally distributed and the variance of x is equal to the variance of y, which means that the standard deviation of x is given equal to the standard deviation of y. It asks about the OLS regression of y on x and x on y on x and x on y on x and x on y. So now let's see. See, when y is regressed on x, the equation that you have is y is equal to beta naught plus beta yx into x. Y is regressed on x. Here in this case, beta yx is given by the formula summation xi yi upon summation xi square. Alternatively, you can give the formula of beta yx as the covariance between x and y upon the variance of x. What is the covariance between x and y? The covariance between x and y is nothing but summation xi yi by n. But if I have to represent things in terms of correlation, because here they have given me correlation as rho. So if I have to represent relationship between correlation and covariance, then I can say that correlation is covariance upon standard deviation of x into standard deviation of y. So in this case, I can say that correlation is rho. Rho is equal to covariance of xy upon standard deviation of x, standard deviation of y. But sigma x is equal to sigma y. So I can simply say that this is going to be rho is equal to covariance of xy upon sigma x into sigma x. So you will have covariance between xy is equal to rho into sigma x whole square. Rho into sigma x square. So now please understand, if instead of covariance, I'm going to put rho into sigma x square and variance is nothing but sigma x square only. So I will get beta yx is equal to rho. Let's stop here. Let's go to the next part. When you regress x on y, the equation is x is equal to beta naught plus beta xy into y. Beta xy is given as summation xi yi upon summation yi square. Alternatively, you give this as the covariance between xy upon the variance of y. Covariance is related to correlation. So the correlation is basically covariance of xy upon sigma x, sigma y. Correlation is rho. Rho is given as covariance of xy upon sigma x into sigma y. But
sigma x is equal to sigma y. So you will have rho is equal to covariance between xy upon sigma y into sigma y. I have replaced sigma x by sigma y in this case. So I will get this as rho is equal to covariance between xy upon sigma y square. So my covariance between xy will be rho into sigma y square. Let me put the value here. This will be rho, not here, sorry, here. So this will be rho into sigma y square upon variance of y is sigma y square. So this is also rho. So one good information that we have got is that beta yx in this case is also rho and beta xy in this case is also rho, right? So beta yx is equal to beta xy is equal to rho. Now, it is given to us that this rho is between 0 to 1. So, because the rho is between 0 to 1, beta yx will be between 0 to 1 and beta xy will also be between 0 to 1. So the answer to this question is B, that the OLS regression of y on x will yield a slope that is less than unity, and that of x on y will also yield a slope that is less than unity. Okay, thank you. DSC 2020, question number 40. Let's see what the question is saying. It says you're given two vectors V and W, and you're given a matrix A, and the matrix A is cos theta minus sin theta, cos theta. So first of all, it says find out what is going to be A into V1. So A into V1 will simply be A cos theta minus sin theta cos theta into V1, which is V1, V2. This is just V, right? I'll put V here, okay? So this is going to be cos theta V1 minus sin theta V2, and then it is going to be sin theta V1 plus cos theta V2. Just multiplying. First row into this into this gives you the first answer. Then sin into this plus this into this. Basic matrix multiplication. Now, it says find AW. So I'll again take my A, which is cos theta minus sin theta cos theta, and I will go ahead and multiply this with W. So my W will be W1, W2. So I will have cos theta W1 minus sin theta W2 sin theta W1 plus cos theta W2. This is my AW. Now it says find the dot product of AV and AW. So the dot product of AV and AW will be to go ahead and do what? V1 W1 plus V2 W2. So which means that if I, if AV is, if I have to go ahead and write AV, my AV will be cos theta V1 minus sin theta V2
sine theta v1 plus cos theta v2. This is AV, and AW is what? Cos theta w1 minus sine theta w2, sine theta w1 plus cos theta w2. So this is your AV and AW. And what do you do in dot product? First element multiplied with first element plus second element multiplied with second element. So it is going to be cos theta v1 minus sine theta v2 into cos theta w1 minus sine theta w2 plus second element into second element, sine theta v1 plus cos theta v2 into sine theta w1 plus cos theta w2. So multiply. This will be cos square theta v1 w1 minus sine theta cos theta v2 w1 minus cos theta sine theta v1 w2 plus sine square theta v2 w2 plus sine square theta v1 w1 plus cos square theta v2 w2 plus sine theta cos theta v1 w2 plus cos theta sine theta v2 w1. Just basic multiplication. This with this entire thing, this with this entire thing, this with this entire thing, and this with this entire thing. Let's cancel out some elements. So you have sine theta cos theta v2 w1, sine theta cos theta v2 w1 cancelled. Sine theta cos theta v1 w2, sine theta cos theta v1 w2 cancelled. And then you are left up with 4 terms. So this will be cos square theta plus, I'm picking up on this, plus sine square theta, I'm picking up on this, v1 w1 plus sine square theta plus cos square theta, I'm picking up on the remaining 2, this and this, v2 w2. Now sine square theta plus cos square theta is simply 1. This will be 1 into v1 w1 plus 1 into v2 w2. So this will be v1 w1 plus v2 w2. But isn't this the inner product between v and w? It is, right? So the answer to this question is A. Okay, thank you. This is DSE 2020, question number 50, MA Economics. Let's see what the question is saying. It says you're given a matrix. The matrix that is given to you is a lower triangular matrix. And now what it is asking is to go ahead and to find the determinant of this. Now see that determinant of 2 matrix A into B is simply the determinant of A into the determinant of B. This is the first thing. Second, determinant of A transpose is the same as determinant of A. Third thing, determinant of A transpose A is nothing but determinant of A transpose into determinant of A, but both are same. So this is determinant of A into determinant of A. So this is nothing but determinant of A squared up. Now, in any lower triangular matrix, the determinant of the matrix is given by the multiplication of the diagonal elements. So what are your diagonal elements? 1, 2, minus 2, minus 1. So the determinant of A will be simply 1 into 2 into minus 2 into minus 1, which will be 4. And here if I put 4 square, it will be 16. So the answer to this question is simply 16. Okay, thank you. The method is the same, huh? You can try it with to the power 1 by gamma also. So it says find the elasticity of substitution between consumption in period 1 and consumption in period 2. Now, elasticity of substitution has a formula which is given by D of ln C2 by C1 upon D of ln MRS. So basically what elasticity of substitution tells us, that if I have any indifference curve and I go ahead and I find the slope of this indifference curve, that's MRS. If I pass a ray through the origin, that gives me the ratio between y-axis and x-axis. So here I'm taking consumption in period 2, consumption in period 1. I'm passing a ray through the origin here also. So basically it tells me as I go from point A to point B, how does not only the ratio change in which I consume the two commodities, but as compared to it, how does my rate of substitution change? How does my slope changes? Both the things are changing if you look at it. So if you notice, not only my slope became flatter, but my ray through the origin also changed. Its slope also changed. So how does this change? This is what this tells me. So it's very simple. If my utility function is C1 to the power gamma plus C2 to the power gamma upon gamma, I'll find MRS. So MRS will be mu C1 by mu C2. So how utility changes when C1 changes, how utility changes when C2 changes. So if I differentiate with respect to C1, I will get gamma, C1 to the power gamma minus 1 upon gamma. And if I differentiate with respect to C2, I will get gamma, C2 to the power gamma minus 1 upon gamma. So this will be C1 upon C2 to the power gamma minus 1. This is my MRS. Now, just one thing here. See, in the numerator, I have C2 by C1. MRS is coming as a ratio of C1 by C2. But we know if I have X by Y, and if I want to switch this, I can write that this is Y by X to the power minus 1. So I can multiply the power with the negative 1 and I can switch what comes inside. So this is exactly what I'm going to do. Let me go ahead and let me say that this is equal to C2 by C1 and switch the power with minus 1. So into minus 1 gamma minus 1. So this will be C2 by C1 into 1 minus
gamma. This will be MRS. Now let's take log on both sides. So ln MRS is equal to ln C2 by C1 to the power 1 minus gamma. So ln MRS is equal to 1 minus gamma ln C2 by C1. Now what do I have to find out? I have to differentiate on both sides and then find d of ln C2 by C1 upon d of MRS. So if I take differentiation on both sides, this has d on both sides. And then d of ln C2 by C1 upon d of ln MRS, this will be given by 1 upon 1 minus gamma. So the answer to this question will be both D. So pretty straightforward question. You just have to know this formula. Achha, a lot of people do this mistake. They start by literally finding ln MRS. So yahan pe na, they would have found out, first they will find MRS, then they will do ln MRS. Then they will go ahead and differentiate that. Then they will find ln C2, differentiate that, and then divide the two. No. In most of the cases, and we know when, if it is a homothetic function, MRS will actually be a ratio of C1 and C2. So you will be able to get your numerator only by solving MRS. See, like this. I got MRS as a function of C2 by C1. So, you know, when I took log, I already had both the things with me. And I just manipulated it a bit and I got the answer. So I don't literally have to find C2 by C1 and MRS and divide. No. I just have to find MRS, see that it will be a function of C2 by C1, and solve for elasticity of substitution. So the answer is D. Now,